Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to talk about another improper integral here. It's going to evaluate the improper integral from negative infinity to positive 1. We got the square root of 6 minus x dx, or they want us to state that the integral diverges. Okay, so remember what an improper integral is. Basically, there's different types of improper integrals, but just general definition, it's basically an integral where you either have negative infinity or positive infinity as one or both of the limits of integration. So in this case, we have negative infinity as our lower limit, but sometimes infinity can be the upper limit, can be negative infinity. An integral can also be considered improper if it's discontinuous on the interval of integration, where it may have finite limits, but it's discontinuous on that interval. So that's what you have to keep in mind about improper integrals. So basically, what you do for an improper integral, since infinity isn't a finite value, or negative infinity in this case, you can't just plug that in there like you would some other definite integrals. So what you have to do is you have to rewrite these integrals as limit problems and evaluate them that way. So I've done plenty of videos on improper integrals if you still don't know how to evaluate these. So the first thing you do is to just rewrite the integral using the limit definition. So just do it this way. Then you replace the infinity here, or the negative infinity, just replace it with a t. And you put your 1 on top. This is 6 minus x dx, and you evaluate the integral this way. So first of all, let's just compute the indefinite integral first and get that part out of the way. Alright, so let's integrate this. Just do a u substitution. So let u equal 6 minus x, and du, that's negative dx. So what you end up with is negative square root of u du. Okay, so this is just negative 2 over 3 u raised to the 3 over 2, and then plus c. And then all you have to do to finish the problem off is to just put, or to finish off the indefinite integral, that is just put the u back in. So the answer is negative 2 over 3. This is going to be 6 minus x, 3 over 2 plus c. So that's what it would be if you were evaluating the indefinite integral. Now we'll go back to the original problem where we had this. And remember, I set it up, and you have to set these improper integrals up this way. They have to be evaluated in this manner. So we went ahead and got our antiderivative. So here's what you got now. The limit as t goes to negative infinity. And remember, our antiderivative was negative 2 over 3, 6 minus x raised to the 3 over 2. And now we need to evaluate this from t to 1. Okay, so hopefully you with me so far. So all you gotta do now, just apply the fundamental theorem of calculus. So you get the limit as t goes to negative infinity, and then when we sub in the 1, we'll get negative 2/3. This will be 5 raised to the 3 over 2. And then we'll have minus minus, so this is going to be a plus. And then we'll stick in the t, so that'll be plus 2 over 3, 6 minus t raised to the 3 over 2. So that's what you get when you plug in your limits. So now all you have to do here is just take the limit as t goes to negative infinity. So when you take the limit as t goes to negative infinity, that'll give you negative 2 over 3, 5 raised to the 3 over 2. And then this will be plus infinity. So negative 2 over 3, 5 raised to the 3 over 2 plus infinity, that's just infinity, which means that the entire value of the integral is infinity, which means that this improper integral diverges. So for your final answer here, when we were asked to evaluate this improper integral from negative infinity to 1, the square root of 6 minus x dx, this improper integral equals infinity, which means it diverges. So that is your answer. All right, so let me circle that for you. All right, so that's going to be your final answer. All right, so let me know if you got any questions. I'll see you guys next time. Y'all take care.